Hi everyone, I'm Yifei. I'm presenting soft fixtures towards practical caging-based manipulation of rigid and deformable objects. As a part of the EU-funded project, we focus on problems of soft object manipulation in the food processing and healthcare industries. Some of these problems deal with restraining objects and reducing their mobility, which is called fixturing. We are making an effort to transfer some geometric methods of fixturing, such as caging, to deformable object manipulation. In this work, we pay our attention to general rigid objects and the class of deformable objects. We model the bending behavior of the fish using links, and the deformation energy is the sum of elastic and gravitational potential energy at each joint and link. We plot the total energy as a function of object configuration. A configuration is a soft fixture if there exists an energy level set that bounds this configuration. As the energy level set moves up, there exists a fracture point that the set doesn't bound the configuration anymore. It corresponds to the escape energy of this object. In practice, we implement sampling-based algorithms to estimate escape energy based on RT star-like methods. To evaluate our methods, we record the configurations of objects over frames and run our algorithms to find escape energy at each frame. The energy of the fish evolves as it drops into a bowl. The fish requires increasing amount of energy to escape as it slides down to the bottom. We are working on some extensions towards a broader range of scenarios and experiments in the real world.